the impact of gut microbiota of acute leukemia, respectively, meaning the impact of the gut microbiota interacting with the chemotherapy particles, has only been examined within mouse models so far. But in those mouse models, we have seen that some chemotherapy particles are actually metabolized by the bacteria of the gut microbiota, so there seemed to be an interaction between those two. In our study, however, it was a clinical study. We didn't directly have a look at the impact on the treatment response, but we simply wanted to see how the gut microbiota are developing over time during the treatment of acute leukemia. Well, we monitored it by taking stool specimens every other week, and we did a quantitative and qualitative analysis of the gut microbiota. So bacterial load was assessed by qPCR, and the diversity was measured in OTUs, and it was analyzed by 16S RNA sequencing. We also wanted to see if the gut was colonized with multi-resistant bacteria. For that, we took anal swab specimens bi-weekly and cultivated them in the microbiology department. And after doing that, we all matched those results with clinical probes, especially from the microbiology department. In addition to that, we had a group of healthy controls. Those were BMI matched. We also took stool specimens from that. And the third group were outclinic patients who were treated for other malignancies, and they had known colonization of multi-resistant bacteria. We also took stool samples from them and had a close look at those ones. We observed an increase of gram-negative bacteria, clearly due to the intensive antibacterial treatment, which had been necessary to avoid infectious complications. However, most of the gram-negative bacteria had to be seen responsible for infectious complications during the course. So, for example, we found most of the gram-negative bacteria first in the microbiome and later on in the clinical probes, so that was quite interesting. We also could find the gram-negative bacteria within the patients of the outclinic department, suggesting that the intensive treatment leads to something comparable to a scar within the patients. These results indicate that the intensive antibacterial treatment, although often necessary, might lead to an accumulation of potentially harmful bacteria itself. Thus, unnecessary antibiotic treatment should be avoided, and strategies to preserve the diversity and to prevent dysbiosis would be helpful to lower or to decrease the complications of infections within patients of acute leukemia.